Me oh my, where has all the time gone? It's time once again for the Daily Space Weather Show. We'll be talking about an increase in the radio flux, a decrease in the sunspot number, and the X-ray flux. Also, another interesting quote will be brought to you today. That and lots more on today's video. We'll even talk about how to count sunspot numbers if you want to check the official data. So that's 30 frames per second, 24 hours. Solar Dynamics Observatory, 171 angstroms. The house favorite will also show ionized helium. And there may be a coronal mass ejection headed our way. We'll cover that as well. I should say, another coronal mass ejection. Also, a coronal hole high-speed stream shall be showing up. We won't talk too much about that as we don't want the video to be unnecessarily demonetized. By the way, if you enjoy the content, don't forget to press the like button. If you're new to the channel, press subscribe. Thanks to everybody who has supported the channel throughout the years. And if people like you have your social media posts actually seen on social media, then by all means, press the share button and tell your friends and foes about the world's most comprehensive daily space weather content. The Smash News Network, least busted name in news. Do you sleep well at night? Well, a quiet conscience makes one strong. Yeah, it helps you to sleep well at night, right? If you have a quiet conscience, you've probably discovered that it's always right to do the right thing and never right to do the wrong thing. It's always wrong to do the wrong thing. Well, you get the idea. And of course, that's part of what makes me sleep well at night. Not talking nonsense about space weather on this very channel. So yeah, a quiet conscience makes one strong. Some words of wisdom there from Anne Frank. And if that quote made you mad, definitely let us know in the comments. Press that comment button and express your rage for whatever reason about such a wise quote. Anyway, moving on, the radio flux has come all the way up to 214 solar flux units. 214 is the new radio flux number. There it is depicted in the past year by that black line up top. And sadly, you can't expect it to continue to rise tomorrow. So it is one of the highest numbers we've seen. In fact, it's the third highest radio flux number we've seen throughout solar cycle 25. You can expect to see continued higher highs and higher lows. So that's the thing. And, you know, keep in mind, folks, you can't know when sunspot maximum actually occurred until sometimes years after it occurred. And of course, people like Bob Lehman are suggesting that this cycle will actually have the second peak be the strongest, like the second half of the cycle feature more sunspots and more activity generally. It's just a feature of oddly numbered sunspot cycles. So sunspot cycle 25 could have a higher second half in terms of sunspots, solar flares, and coronal mass ejections. Of course, it's massively outdone solar cycle 24. It's not even close. And as far as NOAA's forecast, NOAA is only expecting a little bit of high-speed coronal hole high-speed stream. Coronal hole high-speed stream there to show up late Saturday night. So that's a forecast from NOAA. There's NOAA's Enlil spiral, and you can see that CH high-speed stream there reflected in that. And ESA's forecast is a little bit different because ESA has detected a CME this morning. So I suspect NOAA just has to get updated on this one. Little bit of a glancing blow there to arrive late in the day on the 14th into early day 15th. So that's a little bit of a difference from the European Space Agency. You can see that forecast for the CME popping off today, depicted in the Enlil spiral. We'll show you that CME. I had a hard time figuring out if it was far side or earth side. And, well, that helps, because sometimes I actually like to compare notes. Anyway, as far as Earth's magnetosphere goes, things are very calm in the geospace, as you can see here. For the past 4 hours, our geospace magnetosphere movie showing quite low magnetohydrodynamic pressure, according to the space weather modeling framework, which uses lots and lots of variables to create that model. Here's our ground magnetic perturbations map. And of course, as above, so below. So magnetic flux density changes are quite low at the Earth level as well. No real surprise there, as Space weather largely drives the changes to Earth's magnetic field. So that's what's going on there for the past 4 hours. KP is only 1.33. 1.33 is the KP index. Again, quite geomagnetically calm at the moment. We do have some coronal mass ejection impacts, at least 2 on the way, and a coronal hole high-speed stream. So we can expect some upticks in that in the coming days. At ACE, things are slow and diffuse at only 359 kilometers per second and 3.42 protons per cubic centimeter for the density. At Discover, very similar there. So great consensus there among the two spacecraft. Discover showing about 3 protons per cubic centimeter at only 364 kilometers per second. GOES magnetometers are smooth. Expect to see a shakeup in that when space weather shows up starting tomorrow. Next, the heliosphere. So, Earth has recently moved into a North Pole magnetic sector, and it looks like we may remain there for several days as it has grown. So a little bit of magnetic indecision happening on the eastern portion of the solar disk, which is what is depicted there. You can see those fields changing around quite a bit. It is possible that that South Pole magnetic sector will evaporate. It could grow too, but we are able to use that data to do some forecasting. Occasionally, this time, it's a little bit unclear as to what will happen next. Here's our solar line-of-sight field plot, depicting all of the sun's fields, all the way from the photosphere to the solar B field to the polar fields. Which brings us to coronal holes. What evil lurks in the depths of coronal holes? Well, the evil of demonetizing our videos, because if you talk about them too much, the video gets demonetized. So we won't keep saying it because of the C word. Yeah, for some reason the algorithm is so busted that it can't understand the C word. And I don't mean that C word, I mean CH, the feature that we're showing right here, which conveniently shows us the solar polar field reversal process. So we'll show you the view of those CHs from SDO next. There you go. There's our 30 frames per second, 211 angstroms wavelength for the past 24 hours. So one well-defined CH right there, which brings us to sunspots. So sunspot number has dipped a little bit since yesterday. So that was surprising to me. I thought it would continue to rise. Some of those spots must have been counted before we realized it. However, sunspot number still here kind of high at about 172 sunspots. 172 is a sunspot number according to Rob, the Royal Observatory of Belgium. Now let's talk about counting sunspots. Counting sunspots is super easy, folks. Sunspot number is 10 times the number of groups plus S, which is the number of individual sunspots. So let's say you've got, let's bring this up. Let's say we only had 3 sunspot groups, and they were all alpha class sunspots with only one umbra. Sunspot number would be 33, because you've got 3 groups, so 3 times 10 is 30. Each one has one umbra individually, so you'd have 33 sunspots. That's how they're counted. So 10 times the number of groups plus the number of individual sunspots, that's how they're counted. And before we cut to that, let's show this article once again. So this article is great. It talks about all kinds of important things. It's from space.com. Solar maximum, when will it arrive? And when will we know? So basically, a lot of forecasters have now downrated this sunspot cycle, expecting it not to be as strong as it initially appeared. And one of the effects of that is suspecting that it's going to be a longer cycle. So now sunspot maximum is expected by many forecasters in December as opposed to October, elongating the cycle by about 2 to 4 months, which means a weaker cycle. Shorter cycles tend to be stronger cycles. Longer cycles are the weakest cycles. And so that's one of the things. And once again, We heard a lot of people who clearly have no idea what they're talking about with respect to, solar forecasting in general, saying, hey, it's solar maximum all the way back in February of 2023 and March of 2023. Now, we know that probably for millions of years, at least for thousands of years, the sunspot cycle has been almost exactly 11 years. There's very little indication that there's very much of any variation in sunspot cycles. It's very clockwork-like, so it's very unlikely, statistically speaking, to see a majorly different sunspot cycle length. That's how we knew it clearly wasn't going to be sunspot maximum in February of 2023, but I digress. If you want to read the article, it is from, again, space.com. Solar maximum is in sight, but when will it arrive? And when will we know? And of course, the reason why it takes a long time to determine when the sunspot maximum is because you can have double peaks. You can have a flattened initial portion of the cycle. You can have a sudden ramp up and then a slow ramp down. So sometimes it takes a year or two to figure out when you actually had solar maximum. Now, as far as flare probability goes, we got a very high likelihood of X-class solar flares. Once again, just like yesterday, Sunspot 3738, 60+% chance of producing an X-class flare. So that's pretty sweet for all of you Aurora chasers and all of you folks who are just into space weather in general. Of course, that could cause massive radio blackouts, but ultimately we have seen a decrease in the X-ray flux since yesterday. Now, that's what's going on. Let's cut back to sunspots from SDO. There you go. There are the past 24 hours. Again, sunspot 3738 remains the most likely place for large solar flares. However, flaring has been quite minimal for the past 24 hours. Now, we're also going to show you the magnetogram, and there are several delta regions in that sunspot 3738. So again, that's good news for solar flares. And we'll also show, we're going to add 171 angstroms to this because it'll show some additional detail. It's just, perhaps it's just eye candy for you. Now, the leading part of sunspot 3738, that is a south pole oriented umbra, which means the magnetic field lines are pointing down to the sun. The trailing set of umbra, which are shown there in white on the magnetogram, those are north pole oriented umbra with the magnetic field lines pointing up from the surface. Now, you may see some difference in how the plasma orients there. That's what we put the 171 angstroms on there for. And if you look at the sunspots in the northern hemisphere, you can see the same thing, that the trailing sunspot umbrae, the south pole oriented ones, are the ones with the field lines pointing down toward the sun, while the north pole umbrae are the ones pointing up away from the sun. So anyway, that's an additional set of images there that we figured we'd show today, just to add some spectacular detail. As there's so much data available from Solar Dynamics Observatory, it is just a good time. And let's move on to energetic particles and flares. We ain't got no energetic particles. The likelihood is rising, though, as sunspot 3738 gets closer and closer to that western limb. Also, when the coronal hole high-speed stream arrives, that'll also increase the likelihood of seeing proton events, solar energetic particles, as shown here in the ghost proton flux, but at the moment, baseline levels. So we had 2 M-class events in the past 24 hours. There are only minor M-class events, and the background X-ray flux has been dipping for the past 24 hours as well. So that's what's going on for that, and let's move on to 94 angstroms from SDO. See if we can spot where those M-class flares originated from. And not surprisingly, they're from sunspot 3738. Pretty much right in the center of the solar disk there. So again, very high likelihood for X-class solar flares. We'll show those delta regions in great detail when we close out the video. Next, moving on to a solar system forecast. Here's where things are today. We'll advance this 1 week, as we've got a crescent waxing moon right now. If you're viewing the evening skies, you'll see the moon near your zenith. if you're in this part of the planet, the Western world. Anyway, that's where things will be in a week. We will have a gibbous waxing moon. So again, there's that crescent waxing moon. It'll be quite high in the sky when the sun sets. That's what's going on right now over Lehigh Valley, Pennsylvania. The moon up there in the constellation Virgo. Continuing on to our astronomy photo of the day from Jürgen Stein. Very nice. A globular cluster. So that's I think it's the Omega Centauri globular cluster. Globular clusters are interesting in that they're a group of stars, this one containing millions of stars, including many red giants, which are all orbiting a common center of mass. So this could be an old galaxy that's collided with the Milky Way and retained its core, so to speak. Some globular clusters even appear to have a massive radio source at its center, which isn't really any surprise to anybody who understands cosmology, in that if it is a miniature galaxy that's merged with the Milky Way, well, that would be a good reason for it to have a massive radio source at its core. So anyway, that's the astronomy photo of the day. Omega Centauri's globular cluster, located at about 15,000 light years of distance and containing about 10 million stars. It's about 150 light years in diameter, so kind of on the large side. And lots of radiation coming from that sector. Anyway, here comes CMEs, and the data that we have isn't particularly definitive. We're going to cut straight to our custom coronagraphs here because besides that, the available data is not too good. So late last night, a CME happened. ESA has timed it as very, very slow. So that's why it's expected to show up so late, not until Saturday night into Sunday. Is that right? Just a minute. There, we've cut back to ESA's Enlil spiral. And that CME. Yeah, expected to arrive late night on the 14th. So actually Sunday night into Monday is when that's forecasted to arrive. Again, there's the Enlil spiral. We've shown you the data. Let's cut back to that. There you be. So great view of that CME. Not exactly sure where it originated from, as it must have been right at the beginning of our 24-hour video here. So that's what made me think that it may be on the far side, but hey, if ESA says it's on the Earth side, I suspect that it is. For some reason, they're suggesting that most of it will miss to the east. That looks like a pretty direct course. Keep in mind, Earth is moving from left to right from this perspective. But yeah, so that's always a good thing. 2 CMEs on the way, we're hoping, as well as a coronal hole high-speed stream. Here's a little closer view. We've added the 193 angstrom 60-minute running difference to highlight those filaments. And oh, by the way, that's another thing in the forecast for solar activity here is not only are X-flares likely, massive CMEs on the Earth side of the disk are also likely, as the plasma filament in the southern hemisphere is becoming quite unstable. So here's some amazing footage of that. So that huge plasma filament, the one that we've named the smash staff plasma filament, just west of the center disk, is looking like it's hanging on by a thread. So if you see an X-class flare come out of Sunspot 3738, look out. It's going to be highly likely that there are associated coronal mass ejections that could certainly release that filament. So just a massive filament there, and also one to its east. So that one was also named. If you want to name filaments after living people, join us over on Twitter, x.com/smashomash. Follow the hashtag name that filament. Just tag us in the post. Let us know which filament you want named. Name it after living people, your friends, your foes, or even yourself. Let's cut the filaments from Cerro Tololo, Chile. Again, you can see how unstable the smash staff filament is becoming. Still quite massive. It looks like some of it may have either collapsed or ejected there. But that's what's going on. And before we get to bonus features, let's look at the last couple of hours. So there you go. It's holding steady at the moment. Again, with a 60+% chance of X-class solar flares. You get the idea. Bonus features are next. Charging hazards are non-existent. Electron flux is up off the floor, but just barely. The GO 16 especially seeing continued low electron flux with its radiographic measurements. There's a forecast model. NOAA expecting flat levels. We may see even a little bit lower than the forecast there, but hey, what are you going to do? Here's the layer where it's measured. The ionosphere. That's 300 kilometers of altitude approximately, where the F layer is typically located. And man, things are boring in the ionosphere, just straight up boring. Even though the South Atlantic anomaly has moved to the South American coast at the 45-degree west longitude line, things are still boring there in the ionosphere. Things are extremely nominal. No space weather's been coming in for an extended period of time here. So when you see the anomalygram, you'll probably agree. Look at how much white is on that map. Just absolutely average for the past, based on the past 30 days. That's the median for the past 30 days. So it's depicting anomaly in megahertz from 30-day median. Blue is high-frequency anomaly, and red is low-frequency anomaly. And, of course, that shows great the South Atlantic anomaly's location there, right where the negative 45-degree line, the 45-degree west longitude line, meets the South American coastline. We'll also show the global ionosphere nowcast. We've been seeing pretty high levels of electron content over the Pacific. Low levels of electron content over the Atlantic, or over the Indian Ocean, rather, and the Atlantic. That'll help you with GPS errors, by the way, if you know how to read the total electron content map, as I am a regular user of GPS. Anyway, we're going to take a close look at the sunspots here. Now, it looks like we do have some deltas here. Let's see. Let's check it out. It's beta-gamma class. Not really beta-gamma-delta class, but this sunspot, 3738, remains very likely to produce X-class flares. So yeah, multiple regions there where there are deltas. You can see one south of that leading South Pole umbra. Whoops, there we go. So if you look at that leading umbra, the one farthest to your right, you see that umbra to its south. That would be a delta, as it is in very close proximity in its North Pole orientation to that South Pole umbra. Then right in the middle, you can see more deltas. And then also some at the trailing portion. So that sunspot remains a major solar flare player. And let's cut back to filaments to close out this video, because look at the instability with plasma filaments south of that sunspot. So exciting stuff to come. That's the forecast. Thanks for tuning in to the Daily Space Weather Show. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.